How about this one? If you have a mechanism that looks like where the potential energy looks like this versus reaction coordinates, so you're going from reactant to product, okay? How many steps are involved in the mechanism that's associated with, so if you propose a mechanism that's where the potential energy profile looks like this, how many steps are involved in that mechanism? One, two, or three? Okay, answer is two. Okay, so this would be the first step. So this thing right here would be the transition state for the first step, right? And then yeah, what you form during that first step is what you would call an intermediate, a reaction intermediate. And then there's a second step here. Your second step goes from the intermediate, transforms your intermediate to product. Okay, and so you have another transition state here. That would be for your second step. So that's two elementary steps. So typically, for each elementary step, you have a hump, you have a transition state. Let's say you have a reaction between carbon monoxide and NO2, and that produces carbon dioxide plus NO. So what happened here? Your oxygen transfers from NO2 to CO, right? And here's the proposed mechanism. NO2 plus NO2 gives you NO3 plus NO. What happened there? One of the oxygens from one of the NO2s transferred to the other NO2, right? So that's let's say you propose that to be the slow step. And then what happens afterward is your NO3 will collide with carbon monoxide to give you NO2 plus carbon dioxide. So overall, what happened here? If you add up these two reactions, what do you get? Your NO3 cancels out, right? So you have one. And one of the NO2s cancel out, so you have effectively you're converting NO2 and CO into NO and CO2. Okay, so that's your overall reaction right there. Okay, so here's a mechanism that would lead to the conversion of carbon monoxide and NO2 into carbon dioxide and nitric oxide. So based on this proposed mechanism, which one is a reaction intermediate? Is it carbon monoxide, NO2, NO3, or NO? What's a reaction intermediate? That's something that is formed in one of the steps of your mechanism, but eventually that is converted to products, right? So you don't have any of it at the end. So in other words, if I were to be able to monitor the concentration of a reaction intermediate, what would happen? What would it look like versus time? So concentration of intermediate, what would it look like? I'd start with nothing, right? And have I have something, I'll make some, but what happens when I make it? Eventually it converts to product, so the concentration will rise and then it will go back down, right? And reaction intermediates, typically when you propose those, you might propose something that's something that would be not very stable. It's very reactive. It's very transient. Okay, so typically, if you can monitor that, its concentration is not going to build up too much. Okay, it's going to be very low concentration compared to the amount of reactants and products that's going to be involved in your reaction. So you might have something that looks like this. If your reactant, okay, if your reactant goes from like that, reactant concentration versus time, your intermediate concentration might look something like this. Okay, so the fact that it's not obvious that it's there during your experiment suggests that you're not building up a lot of it. But with very sophisticated instrumentation, you should be able to detect some of these intermediates that you can propose in a mechanism. Okay, there's some more advanced laboratory techniques that you can use to monitor very low concentrations. So what was the answer to this? Did I do a poll on this already? Okay. Popular answer was NO3. Why NO3? You made it in step 1, but you lost it in step 2, and you don't have any of it at the end, right? So that's an intermediate. What would be the potential energy profile for this versus extent of reaction, progress of reaction? What would it look like? It's going to have 2 humps, right? And if this happens to be positive, then that would be that would be an endothermic reaction, right? If it happens to be an exothermic reaction, then you'll have to do this down here, right? Uh, you have to have a lower potential energy for the product. Okay, so in an endothermic reaction, the potential energy of the products would be higher than the original reactants. In an exothermic reaction, the potential energy of the products would be lower than the original reactants. So what would you call carbon monoxide here? It's not a reaction intermediate. What would it be? That's a reactant, right? NO2 would be also a reactant, okay? And NO would be a product. What would CO2 be?